Hello again. Let's go over some 7-7 homework help. You were supposed to do start on page 464 and then do 9 through 33 odds. Here's a little walkthrough. So we're just doing the odds, okay? I apologize. I scanned from the book and it blew up and it's kind of fuzzy, but hey, whatever, we're dealing with it. Here we go. So 9 through 33 odd, here we go. Identify the initial amount and the growth factor. 14 initial amount, 25, 600 initial amount. Growth factor, looks like that's doubling. Looks like this is growing by 1%. Remember, a growth of 1% would be 1.01 as a decimal. Okay, here we go. College enrollment, here we go. The number of students enrolled at this college is that many, and it grows by 4% each year. What's the initial amount? That much. If the percent changes by 4%, then you would add 1.04. Okay, so you would use 1.04 for your growth factor. If you want something to grow, you multiply it by 1 point something. Decimal. Remember, percents are pretty and decimals do the work. Find the number of students enrolled after 1 year. You would just multiply it times 1.04. I kind of like this one. It's kind of really breaking this stuff down for you. Complete the equation for number of years. You'd put the starting amount right here, the growth factor here, and then to the X number of years. And then 25 years, well, you would just do this number, this 15,000. You would take it times 1.04. I like to draw it like that, to be honest. Use brackets here. And then 25 years. There you go. Put that in your calculator, see what you get. 15. Ooh, here we go. This is the compound interest. The thing that always gets people is the number of compounds in a year. So here we go. 15. If it's compound annually, that means you only get one payment. So it's actually really easy to figure out. This one, I would go $4,000. Excuse the sound. 1.06 because it's growing by 6%. One time a year for 5 years. Boom. Throw that in your calculator and you're good to go. Number 17. Quarterly is 4 times a year. Okay, so now watch what happens here. The formula changes just a little bit. The reason I don't do all the extra stuff is because dividing by 1 and times 1 is kind of a waste of time. But here you have to physically add the interest rate, which is 4%, 0.04. And then if you get paid 4 times a year, what they're going to do is they're going to make your interest rate 4 times as weak. So they divide by 4. They're going to make it a fourth of its power. But they're going to give you 4 times the payment. So it's got to balance out somehow. Now, 6 years, 4 times, you would go 6 times 4 or 4 times 6. Now, where people are screwing these up is when they don't put it in the calculator properly, okay? This, you can type it like you see it. But this right here, friends, please go ahead and multiply that and enter it as one number. So if I were to do this in my calculator, I would go ahead and throw that in as a 24, okay? Because when people go 6 times 4 in your calculator, order of operations sometimes will mess with you. So money, interest rate, divided by how many payments in a year to the power of years times the number of payments. Okay, you get more payments, but they also weaken your interest rate. Okay, number 19, basically the same one. Quarterly, okay, 4 times. Okay, monthly, that would be 12 times. Monthly, 12 times. Annually, once. Monthly, 12 times. Okay. Number 19, I'm going to set it up here. We'd have $5,000, an interest rate of 1.5%. So we'd go 1 plus 0.015 divided by 4 payments in a year. And then 3 times 4 would be 12. Okay. So again, how did I get that? 3 times 4. I don't even write it out. I just multiply it really quick. That makes things a little bit easier. You're going to get 12 payments. Okay. 4 times a year. It's going to be 12 payments. But your payments are going to get 1/4 of the interest rate. Okay, so they weaken your interest rate, but they give you more payments. You get like 5 more pennies, I think. I don't know. Do more math to figure this stuff out. We should just do the same money with the different interest rates for the same years and then just kind of experiment. But hey, who's got time for that? Hey, look, number 21, kind of an easy one here. So you have $775. Sorry, you can't see the money. It's over here. It's off the screen. You all got the books open. Okay. Now it's compounded annually, so that's once a year, so we don't have to do all the crazy divide by time stuff. You can just keep it regular. Good, because 1.0425, you get kind of a nasty long interest rate there. 12 years, boom, that's it. Plug it in like you see it. Type it just like you see in your calculator. That's why I like these brackets. I like those brackets because now I can just type it like I see it. Okay. 23, identify the initial amount and the decay factor b in each exponential function, okay? Initial amount, decay factor, looks like that thing's getting chopped in half. It's losing 50%, so that means it's keeping 50%. Again, I like to write it like that. That's just me, okay? Let's see here, 25, there's your starting amount, there's your growth factor, which is your decay factor. 2/3, I think they're probably losing a third because they're keeping 2/3. Again, the number that goes in here for decays is what you keep, not what you lose. And that's all we needed to do. Okay, cool. The population of a city is this many. It decreases by 2% each year. So what do they keep, students? Well, if you lose 2%, that means you're going to keep 98%. This is going to be the number that you actually use in your model. So I would take the current population P of people, you can plug in the numbers, and then I would take that times 0.98. And that's happening each year, and then take that to the power of 15. So again, I'm not going to write the whole thing out for you. Put this number right here, do the rest of it, hit enter. Now we're talking about people, so you probably want to round to the nearest person. Okay, that's a whole other story that we should talk about, is when is it appropriate to round to the nearest whole number, nearest decimal, nearest whatever. Well, it kind of depends on what you're talking about. When we're talking about money, you should probably round to the nearest cent. Okay, talking about people, the nearest whole person. You don't really want decimals and fractions of people because that just gets weird. Here we go. State whether the question is an exponential growth or an exponential decay or neither. Okay, so number 29. I'm going to do all of these really quick. Growing, decaying, nothing. Okay, look at this. Times x squared. There's no number here. Well, technically there's a 1, I suppose, but then you just, that's nothing, bro. And then let's see here. You are a decimal, so that means you're going to be decaying. Okay. 0 point something, you're going to get smaller. 0 point something, you're going to get smaller. Times 2, it's going to grow. Okay. There's the last question, number 33. Ooh, I like this one. Sorry, I kind of screenshotted some weird parts of it, but that's all right. That was all the way to 31. Okay, here we go. 33, this is the last one. Okay, a family buys a car for that much money. The value of the car decreases about 20% each year. After 6 years, how much is the car going to be worth? Should they sell it for $4,000? Well, here we go. So I would take the $20,000 they bought it for. I really need that comma. Now, if you lose 20% of your value, that means you keep, that means you keep 80% of your value. I really don't care how much I lose. I want to know how much I keep. So I would take that 20,000 times 0.8. How many years go by? 6 years. Boom. Okay. So put that in your calculator, see what it is. Should they sell it for $4,000? I don't know. If this number gives you a higher value than 4,000, then they're underselling themselves. But if this number is just a little bit under 4,000, yeah, sure, why not? Try to ask for a little bit more than what it's worth. You never know. Okay, but if it's definitely more than 4,000, no, you're underselling yourself. More is better in this case. Always try to sell it for a little bit more than what it's worth, because you never know what's going to happen. Okay, there you go. That's the 7-7 homework help. Hopefully that was helpful to your homework.